Hi, everybody. I hope you're doing well. I know that length of a sector, the piece we just did, and today we're going to do area of a sector. They can be a little complicated and cause some confusion, but they do come up on some standardized tests that you'll be taking for college entrance, okay? So I do want to just have you exposed to them. The thing to remember is that the length of this sector that we just did in '06, that is a proportional relationship to the whole circumference. And how much of a proportion depends upon how big the central angle is. And the area of this sector is a proportional relationship to the circle's area. So it's a piece of the whole circle's area. Okay, so if you think about it that way, you're not going to get confused because there are no formulas given for this. Like, you have to kind of know what to do. Not that you're taking any real tests. You can, but even on the SAT, ACT, the best way to do the problem is to proportionally relate it to how big the angle is. The bigger the angle is, the more of the circle's length, either circumference you have, so use circumference, or more if you're doing area, the bigger the angle, the more area of the circle you have. Okay? That's what I would explain to you if I were standing there with you in front of you and demonstrate. So these numbers are off because our remote learning has made things change a little bit. We're up to '07 now. Area of a sector of a circle. Okay? Just a review question, what is the area of a circle with a radius of 6 centimeters? It might help some of you to draw a diagram. Okay, area is not 2 pi r, that was circumference that we just used. It's pi r squared. So for area, we're going to get 36 pi. And the biggest confusion on these problems at '06 is mixing up the circumference and area formulas. Okay, that does happen. On the SAT, ACT, the circumference and area formulas are on the reference sheet. But, so they're given to you. You just have to use them in the right place, okay? A sector of a circle is a portion of a circle enclosed by 2 radii and an arc. It has to be a central angle, and it resembles a pizza slice, okay? So we did length of a sector already, so you know what a sector is. We're talking about the area of a sector. Now we're talking about all this. We want to know how much space is taken up in there. Okay, so it's just a piece of the circle. And you're going to use the same proportion that we used before, except for now we're doing area of the sector over the area of the whole circle is the central angle over 360. So this stuff is the same. Okay? There's really not much to teach you more on that. I will do a demonstration, some problems for you. A circle with a diameter of 10 and a central angle of 30 is drawn below. What is the area to the nearest tenth of a square centimeter? So I'm going to be calculating and putting the pi in my calculator. I'm going to be rounding of the sector formed by the 30-degree angle. Okay, sometimes in these problems we're asked to leave it in terms of pi, and sometimes we are asked to round. So it depends upon the situation. Okay. First thing I want you to notice is this question is giving you a diameter. And in almost all the time, in geometry, almost every time, I would tell you when we were doing, like, at the end of the year, I would say, whenever they give you a diameter, change it to a radius. Giving you a diameter is not helpful because your area formula is in radius. Your circumference formula could be diameter. That could be. But if you work always in radii, you won't make a mistake. You need it for volume. Radius is just the best way to go, okay? So the first thing you're going to do in this problem is you're going to, as good students of geometry, say they gave me a diameter. I know the radius must be 5 centimeters, half of the diameter. Okay, so now we want to know how much area this little section is taking up. Okay, so in other words, this is a pi for Pi Day. This is a pi, and you're getting a slice this big. What area are you getting? Okay. although that would technically be volume, but you know what happens when I try to use an example, then I start to overthink it, because a pi is three-dimensional, so it's really talking about volume. But if this was a piece of paper and you were getting this piece of a section of that paper, how much paper would you be getting? Okay, so we have to figure out the area of the whole circle. So I like to do that right off the bat. The area of the circle is 25 pi, right? Area of a circle is pi times r squared. All right, and then, so we want to know, how much did we get out of the whole thing, part over whole, equals, well, how big is our part relates to its central angle. Bigger the angle, more of the piece we get. 30 degrees over 360. Okay, now think about this. If I wanted to know from here to here, that would be half of the circle, right? So you would divide the circle by 2, the area by 2, and you would get your answer, 12.5 pi. All right, what I want to show you is a couple of things when dealing with these proportions. As advanced students, you should be getting better at and faster at, but since we're not together, you don't see me doing these. I don't want to deal with these numbers. I can put them all in my calculator and it's fine. But as mathematicians, you want to get a little bit faster. First of all, 10 goes into both of these. So now instead of 30 over 360, I'm really dealing with 3 over 36. And 3 goes into 36 12 times. So really, this proportion is a 1/12. 30 is 1/12 of 360. If you don't believe me, you can check that out on your calculator and just do 360 divided by 12. I'm giving you a chance to do it, and you get 30, okay? Or 360 divided by, if you do divided by 30, because you wouldn't have had the 12. You get 12. This is 1/12, okay? You can also put in your calculator 30 over 360 and have it reduce it to 1/12, okay? You could have done this on the problems on 06, but I just didn't want to complicate things for you. But if you see shortcuts like that, things that reduce, by all means, go ahead and use them. So when I cross multiply now, I end up with 12x equals 25 pi. And I'm rounding, so I'm going to divide by 12. I'm going to put this into my calculator. 25 pi divided by 12. And I get the section is approximately 6.5 to the nearest tenth. So 6.54 is 6.5. So there we go, 6.5. Okay. Now, if you didn't like that shortcut and you want to do the whole way out, if you do 30 times 25 pi divided by 360, you're going to get 6.5 rounded to the nearest, I won't put equals, rounded to the nearest tenth. You're going to get the same value, okay? So you could do the shortcut just to shorten things up for yourself if you like. Okay, triangle FGH is inscribed in circle O. The length of OH is 6. That means this is 6 and this is 6. This is not 6. Okay? And FH is equal to OG. So that's what's it called? An isosceles triangle. What is the area of the sector formed by angle FOH? So what we're looking for here is this. We need to know how big that central angle is. Okay. They didn't give us any angles or any arcs. We had to find some ourselves. All right, we could do this. I wish I were with you so I could ask you questions. What arc, do you know any arcs? or any angles? Look at it for a second. Hopefully you're seeing this arc. Yes? And then you're thinking about something we learned about this angle. I hope light bulbs are coming on. This is an inscribed angle to a diameter or to a half a circle, a semicircle, so it's 90. Okay. Now, this is a right angle with two equal legs. Isosceles right triangle. This angle is 45 and this angle is 45. Looking at the big triangle FHG, a 45, 45, 90. Now this triangle here, FOH. Look at triangle FOH. Triangle FOH is also isosceles. So it's a 45. That's 45. This has to be 45. So this has to be 90, even though it doesn't look like it. Okay? So that was pretty convoluted, but this arc is 90 degrees. Okay, now, what part of 360 is that? 90 out of 360. If you can simplify that and make that fraction smaller for you, please do that when you do this problem and use that smaller fraction. Otherwise, we're going to do the area of the sector over the whole area. What's the whole area? Pi r squared, 36 pi. Okay, so there is a shorter way with smaller numbers. If you can simplify this fraction in your head would be the best way to do it, or on your calculator, because if you're doing it on your calculator, you might as well just do the whole problem on the calculator. Okay, I suggest you do the algebra out. Whoops, that's a highlighter, sorry. 360x equals 90 times 36 pi. Divide by 360, divide by 360. Use your calculator to get this value. Okay, that was hard. Yikes. Okay, that was hard. Number 3, in the diagram below of circle O, GO is 8. Okay, that's a radius. And the measure of angle GOJ, central angle, is 60. What is the area of the shaded region in terms of pi? All right. Now, there's two ways to do this. You can either find this shaded region and minus from 360, because that's not what we want, or you could find this angle and do the problem that way. So you pick the way you want to do that one. You either use 300 as your central angle, or use the 60 when you get the area of sector GOJ, minus it from the whole circle, because you won't be getting the whole, you'll be getting the shaded part and you want the unshaded part. Okay? In the diagram below of circle O, the area of the shaded part is 12 pi inches squared and the length of OA is 6. How big must the angle be? Okay? So we know what the shaded sector is. 12 pi in inches, square, so square inches is the unit. You don't have to worry about that part. Okay, it's just a unit, and not that units aren't important, but for the calculation, you don't need it. The length of OA that's the radius, is 6 inches, so this area of the circle is 36 pi. Okay, so remember, we're dealing with ratios, so we want to know what ratio part is that? Okay, it's like, what angle is that out of 360? You could solve that proportion and get the answer from that. Or you could figure out what this equals. The pi's cancel, and 12 out of 36 is 1/3. And then 1/3 of 360 is, you could do it that way. So there's two ways to do it. I'm not going to do it for you. I want to get into this, alternate ways to find arc length and area of a sector. So we already did arc length in lesson 06, and this 107 was finding area of a sector. There's another way to do it if you deal in radians. Okay, if you deal in radians, you can use, well, the SOAR formula, it's called. Okay, now this formula right here, this is the same thing we did. We did this. It's not really alternate. I don't know why I wrote alternate there. SOAR is alternate because it uses radians. This is just taking the regular formula that we had and solving for area of a sector. So you do central angle over 360 times area of the whole circle. Okay, that's what this formula is. Okay, you might see that somewhere. If you looked it up in, let's say, Math Bits, you'd see a formula that way instead of the proportional way that I do it. But if you're dealing in radians, the SOAR formula is a fabulous, it's very quick, very easy. And some students are using this on the Regent exam the last couple of times, and it can be used on your SAT, ACT. So that's why I bring it up. In a circle with a diameter of 24 centimeters. Radius is 12, just to be sure. A central angle of 4 pi over 3 radians intercepts an arc. What is the length of the arc to the nearest tenth of a centimeter? Okay, if you use this, people will call it, and in Algebra 2 you're going to hear about it, it's called the SOAR formula. Okay, so it is the length of the sector equals the angle in radians times the radius. That's it. It's right here, all this stuff right here. So you're going to get S equals 4 pi over 3 times 12. 3 goes into 12 4 times. It's 16 pi. To the nearest tenth of a centimeter, get your calculator out and do 16 times pi. Okay? So this was a multiple choice question from a Regent exam. With this, the Regent exam loves asking questions like this. Here's the students, this one, this one, this one, and this one. As a matter of fact, this question was one that was wrong. Remember, maybe you were too young to even remember. You probably weren't even in Cary yet. The Regent exam, I'd have to look up the year. One of the Regent exams in Common Core Geometry had 3 mistakes on it, and they had to give the kids back points. You might think, wow, I wish that happened to me. Hey, you got the whole Regent exam back with no points. So you don't have to even worry about it. You don't have any points to deal with. But this question was marked incorrectly on the Regent exam. Anyway, 4 kids did the problem, and they used different proportions. They did it different ways. Which students were correct? 2 of them are correct, and 2 of them are incorrect. And so maybe you could play with that one as a challenge. Okay? That's the end of the how to find the area of a sector lesson. As always, if you have any questions or problems, please email me. This lesson will not be due until Monday. No, I'm posting it on Monday, so it won't be due until, I don't know. You can see when I post it, because I don't even know. It's Friday now, so I'm confused as to what day it is. All right, hope you have a great weekend, or you had a great weekend if you're doing this Sunday night in the middle of the night or whatever. No, it's Monday already. I don't know. I'm sorry. I can't delete what I just said because I can't go back. So you're going to hear my rambling about not knowing what day it is. All right, have a good one. Whatever day it is, have a great day. Miss you.